So we're picking up with our discussion of what is a VLAN, or a VLAN overview. So you might be asking yourself, why would I even want to configure VLANs if I have to have a router in the middle? You've got a single point of failure, which really isn't the case either. You can use redundancy protocols, but I'm getting ahead of myself. It's more administrative overhead, it's more accounting overhead. Why would I want to go to all this trouble? Why wouldn't I just drop everything into one big happy network and let everybody talk to everybody else freely and openly? Well, the first reason you might want to configure VLANs is security. Since you have to route between VLANs, it's a good place to do packet filtering. If you have a router there, you can configure it as a firewall and only allow certain traffic through based upon the access list that you configure in that router. If it's a truly high security installation, you can put an ASA or some other type of firewall, but since they are on two different Layer 3 and Layer 2 networks, then you can do any type of filtering you want. Let's say that VLAN 10 is your DMZ, and you only want certain hosts in your DMZ to communicate with certain hosts on your internal network on specific ports. This is where you would configure that, in the security appliance between your DMZ VLAN and your internal network VLAN. The second reason you would want to configure a VLAN is for voice over IP. Best practices state that you should keep your voice and data on separate VLANs. And again, some of this goes back to security. You don't want people to easily be able to sniff your VoIP traffic because VoIP by default is unencrypted. You could just hook up a packet sniffer and pull off the 802.11 packets and replay telephone calls were you inclined to do so. Also, another reason that you would keep them on separate VLANs in a VoIP environment is so that you can tag your voice over IP packets with a higher DSCP or a higher QoS value, so that your WAN links and your MPLS or your frame relay provider treat that traffic differently and give it priority over just your regular bulk data traffic. And the third reason, which really isn't a technical reason, but it's more of a management reason, is it's more manageable if you have separate VLANs for servers and workstations and core networking. You can look at an IP address and figure out, okay, well, it's in this IP network, it's in this VLAN. That means it is a core voice over IP device. That means it is a core router. That means it's in our DMZ. That means it's at this location. And again, this goes back to some of the administrative and technical overhead that we mentioned up on our first point here of why would you even want to configure VLANs. But trust me, if you have VLANs for separate floors or separate departments, it makes your life a lot easier when it comes time to figure out exactly where is this host that's spewing all this bad data on the network. It's easier to say, well, this host is somewhere on the 15th floor rather than this host is somewhere in this 25-story building. Now, there's two basic ways of configuring VLAN ports, and we'll see how these methods differ from each other in their actual technical configuration when we get into our lab here in a few videos. The first is to set a VLAN as an access port. You go into the switch, you configure the switch port to be in a single VLAN, and all the traffic gets put on that single VLAN. If you configure it in a data VLAN, you could never get to your voice VLAN through that access port. It's generally a good security practice for ports that are pointing at your user population to be hard configured as access ports. If you let users negotiate a trunk configuration, which we'll go into here in a little bit, then they could potentially learn a lot more information about your network than you might want them to. The second way of configuring a VLAN port is a tagged port. You configure the port for multiple VLANs. The device that's connected to that port is responsible for tagging the traffic to be in the correct VLAN. So you would go into the switch configuration and you would say, this port is a tagged VLAN port, and Cisco generally calls it a trunk port. And the switch will allow tagged traffic on any VLAN you specify to come in that tagged port. Now again, for the most part, these are not ports that will point at users. These are ports that will point at other switches or other routers, because generally the only time you'll use tagged ports will be for switch port trunks, which we'll actually cover in the next video. Now, to be 100% technically correct, if you do set up a Cisco VoIP environment and you set up a voice VLAN and a data VLAN, then technically the switch port is a special kind of tagged VLAN port or a special kind of trunk port, but the only device that can connect to that tag port is a Cisco phone, so it's not a violation of any security policies or security best practices to configure it in that way. And that concludes our overview of VLANs.